Greetings of the day, students. Today we are discussing Introduction to Functions. The subject name is Discrete Structure with code CS302. This subject is basically in the curriculum of BTech CSC third semester. Functions. Basically, a function is relation between two sets. Let's say we have two sets. First one is called A, set A, and the another one is set B. There are n number of elements in set A and m number of elements in set B. These sets A and B, the condition is they should be non-empty sets. Now, every element of first set, which we have named A, must have one image in set B. Here we can understand the concept of function with the help of diagram. See, there are two diagrams. The first one, which is having a correct tick mark, and the second one which is having a cross tick mark. Now let's see the first diagram. In first set, the pink color one, which we would be calling set A, it is having three elements 1, 2, 3. The second set, which we would be calling set B, is having elements P, Q, R. Now two types of mapping, or you can say two types of functions, are shown here. In first diagram, the elements of set A, those are 1, 2 and 3, are having 1, 1 images in set B. For element 1, the image is P. For element 2, the image is Q. The element 3 is having image Q as well. Now we move on to understand the second function, that is the second diagram. In this diagram, if you observe that in set A, element 2 is having two images, or we can say two mapping in set B. So the element 2 is mapped with element P and element Q in set B, which is not allowed, which is not possible in functions. So that is why the cross mark is put here, that it is not a correct function. So the condition for function is that as we are mapping set A with set B, so first set elements cannot be mapped with two elements of set B. That means one element in set A cannot have two images in set B. So the conditions for a function is that as we are making a function between set A and set B, so these sets A and B should be non-empty. There must be some elements in them. Then as we are mapping from set A to set B, so elements of A is called domain and B elements are called codomain. Then there are few elements in B which are being mapped with the elements of A. So those elements which are mapped, they will make the range of the function. There is one vertical line test which determines whether the curve or the relation is a function or not. Let's say we are making a function between two variables. Now represent these variables on the two axes and represent the function through a curve. Now if this curve cuts the perpendicular line on the one of the axes, then this is not a function because the elements are having two images, or two elements are mapped with one element on the other variable. Now there are some important terms related to functions. Those are domain, codomain and range. Talking about domain, if we are making the function between set P to set Q, the elements of set P would be mapped to the elements of Q. So whatever the elements of set P, those are called domain of the function. Now codomain is the elements of set Q, because these elements of set Q are images of set P. Now range, there may be possibility that all elements of set Q are not the images of set P element. Only those elements of set Q which are images of elements of set P are called range. So if you observe, there is relation between codomain and range. Basically, the range of the function is having lesser size as compared to the codomain of the function. This diagram clearly shows the concept of domain, codomain, and range. We have two sets. Although both the sets are having same elements 1, 2, 3 and 4. See, the left hand side set, we will call it set P. Its elements are mapped with the elements of another set that is represented on the right hand side. Now from first set, element 1 and 2 are mapped to element 2 of the second set. Then element 3 and 4 are mapped with element 3 of second set. Now in functions, all the elements of first set are being mapped. So the first set, its all the elements are the domain of the function. Whereas the second set, the complete second set, is called the codomain. But only those elements of the second sets which are being mapped, for example, element 2 and 3 here, those are called range. So in this example, the first complete set containing elements 1, 2, 3 and 4 is the domain of the function. Then the second set, complete second set containing elements 1, 2, 3 and 4 is the codomain of the function, and the range is element 2 and 3. Here we can see the concepts through one example. There is one function defined from set x to set y. Function f is defined from the elements 1, 2, 3 and 4 of set x towards element a, b, c, d and e elements of set y. Now we have to find the function's domain, codomain and range. As we have already discussed, that domain of the function is the set x, the first set. So whatever the elements in the first set, that is the domain of the function. Moreover, the codomain would be whatever the elements of second set is, and the range would be only those elements of the set y which are being mapped with the elements of set x. Let us analyze the solution. Domain of the function, the whole x set elements, that is 1, 2, 3 and 4. Range of the function is only those elements of set B which are having mapping with the elements of set A. So these are A, B, C and D. And codomain of the function is whole set Y that is A, B, C, D and E. This was a short introduction of functions. Happy learning, students. Thank you.